Good evening, everyone. I am Dr. Pratibha Jadhav, and I warmly welcome you all to the 8th session of the Parivartan Webinar Series, proudly organized by Plastindia International University, Vapi. The Parivartan Webinar Series offers a dynamic platform for experts in plastics, polymers, artificial intelligence, and sustainability. To set the context for today's session, let us now go through the guiding principles and aspirations of Plastindia International University, addressed by Dr. Prashant Gupta, Senior Assistant Professor, School of Engineering, PIU.
Which is Plastindia International University, is a not-for-profit institution which is founded by the plastic industry for the plastic industry. So as you can see in front of your screen, our parent body being Plastindia Foundation is interned by a host of industry bodies, of which the major ones are All India Plastics Manufacturers Association, there is CIPID, then there is Organization for Plastic Processors in India, OPPI, Flex Council, Indian Plastics Institute, GSPMA, and IPF as the main members, and CPMA, PMMA as constituent members, and a few associate members as well. So we are a university which has been set up with a clear vision of how we can give back to the industry and educate the students as a part of this process. Our vision is to develop world-class university in plastics technology, research, and innovation. We are conveniently located in the city of Vapi, which is roughly 150 kilometers from the city of Mumbai on one side and roughly 120 kilometers from the city of Surat on the other. Now, why Vapi is, if you look at the belt, which is roughly a 30 kilometer radius from the city of Vapi towards Mumbai, we have Umargaon, and going further, we have Vasai and all. And when we go towards Surat, we have Valsad. So, if we look at this 30-kilometer radius with Dadra and Silvassa on one side and Daman on the other, we are looking at a major plastic sector or a processing cluster of the country. That is the reason why this university has been set up in the city of Vapi. We have academic partnership. It's a technical partnership with University of Massachusetts Lowell, which is a sister institute of MIT that we have in the USA. This Lowell campus is situated around 60 kilometers from Boston. So there is a growing need to increase employability through skill development programs in India, and that is the effort that we want to bring in. Plastindia International University, as we have already mentioned, has signed an MOU which was just renewed in the month of April, the first week of April, where we have extended it for another 5 years. We just look at the criteria under which this technical partnership has been strived out. Designing of curricula and modules in plastics engineering. So Professor Maski also happens to be a part of our academic council and board of studies as well, where we have industry stalwarts and academic stalwarts like him, helping us to, modulate our syllabus in collaboration with UMass Lowell. So whatever is being taught at UMass Lowell, we are teaching them, and then we are trying to fill in the AICT criteria that is there in India, which is 160 credits. I mean, in the US, the credits which are required to be passed out are lesser. And then we have also included subjects based on the local knowledge that is required, at least to serve in India. We have student and faculty exchange for research based lectures, discussions, applied research, and community based projects. There are opportunities for engaging students and researchers to have a like for like peer relationship and to have a mentoring opportunities. Some of our students can mentor their students, and it can work likewise like that. There is also a criteria which is signed up with respect to faculty development. So faculties from PIU WAPI will be sent to UMass Lowell for their training, and there will be a faculty development program which will run up to an year in these terms, and conducting a webinar series in technical partnership. So we are looking at the second of this series. First, we have already done the last year. For those who don't know about UML, it's a 70-year-old presence. They've been teaching plastics since 1954. It's a leading institute in plastics technology. Now, why one should think about PIU? There are a lot of institutes which are running, programs like polymers. Very few like ICT, which have been specifically focused on a particular domain, like ICT focuses on chemical technology and chemical engineering. And in the same way, PRU focuses just on plastic and polymer engineering and technology. So we are not just a course, but an exclusive university which is focused on just the plastic and polymer engineering courses. We have industry-driven education, so we have very close ties with industry partners, and hence our curriculum is basically futuristic. It is not what we require today, it is what is going to be required in 4 years or 5 years down the line. Very strong industry integration and hands-on learning. We have a guaranteed placement which is 100% guaranteed in terms of getting placed. We have scholarships and financial aid, so we have our own industry based scholarships, and then we have these government scholarships as well. And all in all, it's a gateway to global education and excellence where we run programs where students can go to UMass level, get into a global immersion and a cultural exchange as well. Now, the scholarships that I was talking about, there are four different categories. One is merit-based, where we give you scholarship based on your marks. There are need-based financial aids. There is industry-sponsored education and government scholarships, as we are UGC and AICTE recognized and approved institutes. Needs-based financial aids are for those students who are coming from economically weaker backgrounds. So the return on investment is really very high, and we guarantee placements. We also run a refund policy where if a student comes up with a 6.5 CGPA, and if we can't guarantee a placement, we give away the fees which we have taken from the candidate in the past 3 or 4 years. These are global faculties. So on the left hand side, you can see the faculties which are there at UMass Global. And on the right hand side, we have a lot of industry experts, both in plastics and polymer and computer science domains as well. Country, even our visiting faculties are having PhDs from reputed institutions like VIT and all. And I mean, the lowest that we have in terms of experience is 3 years, wherein the highest that we have in a small team that we have at the current point in time is 30 and more years. We run these two programs where we have a BTech in plastics and polymer engineering with the first year and a direct second year entry at this point in time this year, and a computer science and engineering. These are some of the companies with whom we have signed MOUs at this point in time in the first year itself, who have very openly welcomed students who will be passing out in their companies for placements. This is an annual tuition fee, 75,000, may increase by 10% this year, and a one-time deposit of 12,500. We have 30 seats to be taken from Gujarat and 30 seats from all India. The eligibility is very simple and it's very similar to what we have in almost all the parts of the country, which is PCM 10 plus 2, 45% of theory and practical marks for general candidates and 40% for reserved categories. When we are talking about an entrance exam, JEE mains or good set, which is for Gujarat suffices. Or if a student is coming from a diploma background, he should come up with a 45% score in open category and 40 in reserve. So this is the campus that we have. Just a few glances about the campus because we are connecting virtually. This is School of Engineering building, and this is the campus that we have, which is roughly around 37 acres. This is our front gate, the entrance gate to that 37 acres of educational excellence. This is the School of Engineering building. I am currently seated on the ground floor of this building. This is our classroom. So we have interactive learning environment with smart classroom equipped with modern teaching technologies. So these smart boards are interactive in nature. A student can connect with their own laptops and interact with the faculty on digital panel. This is a group of students performing chemistry experiments, viscometry for molecular weight. This is our workshop and processing house. Again, students operating the machines, state-of-art laboratories. We have a computer lab with 60 seating capacity, a lab which is very identical. So we run software-based English language curriculum where we have 2 semesters, theory and practical, where softwares in terms of English language help the students with respect to listening and speaking skills, whereas the theory part takes care of the reading and the writing skills. We also have a 3D printing laboratory, and in both the semesters, first and second, we expose our students to subjects such as design thinking and innovation. This is our library, both digital and the analog that we have. Sports and recreational facilities, yoga, important for mindfulness, focus, and overall well-being as well. Hostel facilities that we have, fully furnished 1 BHK and 2 BHK apartments, being given at a very, very lower price. Just a glimpse of our students collectively, standing outside the campus. There's a cafeteria and common room separate for both girls and boys. Just an image to, foresee what is to happen in the future. We'll have our own buildings for the School of Executive Management, School of Sustainability, and School of Continuing Education, along with an auditorium. So this is the plan that we want to have in the future. With this, I'll end up my session and I'll pass it on back to Dr. Jadhav. Thank you for listening.
Thank you everyone for listening patiently. Let us now move ahead and introduce our speaker for the today's session. We are delighted to welcome Mr. Rajesh Pahwa, a seasoned professional with over 3 decades of industry experience in the field of polymers and packaging, one of the pioneers in the Indian master batch and compounding sector. Throughout his career, he has played fundamental role in driving innovation, optimizing production processes, and advancing sustainable solutions within plastic industry. His deep expertise spans across plastic material development, color and additive master batches, and customized polymer compounds for diverse applications. Mr. Pahwa has actively contributed to the growth and modernization of the polymer industry in India, consistently promoting the adoption of eco-friendly and recyclable materials. He has been a part of various national and international platforms sharing his insights on polymer technologies, sustainability strategies, and the role of plastics in the circular economy. His collaborative approach and industry foresights have made him a respected voice among manufacturers, educators, and policymakers. Today, Mr. Pahwa will be sharing valuable perspective on how India's bold EPR regulations are creating transformative opportunities for the plastic recycling sector and how innovations, policy, and collaborations can drive $5 billion circular economy. Before we start the main session, I request all the participants, if you have any questions during the session, please put it in the question and answer box. Mr. Pahwa, we are delighted to have you. Please take the session forward. Over to you, sir.
Thank you, Dr. Radha. And it was wonderful presentation from Plastindia International University. Highly
Thank you.
impressed with the kind of work PIU is doing. So I'm into recycling for a long time, as you shared earlier. So is my slides are visible?
Yes, sir. Your screen is visible.
Okay. So let's start with, I am Rajesh Pahwa and my company name is Sourcery. Sourcery is a subsidiary form of Source One, a tech-based company who is leading in virgin polymer suppliers. And they are the largest suppliers of virgin polymers in India. Now we have started Sourcery, which is circular arm of this Source One. So what I want to share about, as you shared, is plastic recycling, its advantages on environment, environment benefits, and social benefits and economical benefits. So what are these importance of plastic recycling? And second is challenges. Third one is opportunities we have in recycling. With the help of new rules, extended producer responsibility rules, there is huge responsibilities and a lot of funding is coming up in this sector. Yes, there are some myths and facts also. I want to share details on those also. Let's start with the importance of plastic recycling first. So as I shared earlier, environment benefits of recycling is recycling reduces the volume of plastic waste in landfill and oceans. We all know that today plastic is very important, amazing material. It's cost effective, highly you can produce in high production. And when you end of the use, of course, there is a simple mantra of reduce, reuse, and recycle. We need to reduce the consumption. That is one thing. Second is reuse. If we can use a product again and again, That is really very helpful for the environment. And third one is after end life of this plastic, we need to recycle it. Recycling not only reduces landfill size, but also lower greenhouse emissions by reducing the need of virgin polymer production. It saves natural resources, replacing virgin polymers. Economic benefits are there, create jobs in the recycling, manufacturing industries, waste collection, waste segregation, generates revenue from the sales of recycled materials. Of course, this is a purely self-sustainable business and reduces cost associated with the waste management and landfill. So we all know that there's a high cost in waste management, collecting waste from households or pick up from the roadsides and identifying types of plastic, segregation. After that, recycling, it involves a lot of cost. So after selling the recycled material, it covers the cost also. Social responsibility is also there. Recycling promotes sustainable living practices with communities. It also enhances public health by reducing environmental pollutants. It also encourages corporate responsibility and ethical business practices. So let's discuss more about environmental benefits. So as Dr. Radha shared that I'm into this sector for a very long time. When I started recycling, plastic was not a bad material at all. It was a life savior. It was saving a lot of trees to be cut down to make papers. And but now there's a very big hue and cry on it is a bad material. I believe plastic is not bad, but yes, litter is bad. So what are the environmental benefits of recycling? Is it reduces pollution. Carbon footprint created by recycling of any waste is much lower than producing a virgin polymer. Reduction in greenhouse gas emissions, ecosystem protection, prevention of wildlife harm. If we are recycling means someone is there who is collecting waste. Someone is there who is disposing waste in a responsible manner. So it will not go into oceans, harming fishes and water bodies. And someone is there who is saving cows that they are not eating this plastic waste. So it helps in preservation of marine ecosystem also. So how we recycle plastic? What is the process? So first is collection. Collection is happening in many ways. One is from industrial waste. So there's always a post-industrial waste there that can be collected and recycled in a recycling center. Second is collection from the post-consumer waste. The waste I am consuming as a consumer, that goes into recycle bin after its use. And there's a very good mechanism in India of a waste aggregators and collectors who identify types of polymers, segregate them in types of polymers, and then colors by colors also, and then goes to recycling unit. The process there is again sorting if there is any contamination. Second process is cleaning, size reduction by shredders or grinders, and then after shredding, there's a process of washing. After washing, you melt it in an extruder, and then it can be molded into other products. So it's like a magic, your toy is broken and it can be converted again into toy, or if you want to, it can be converted into any automotive part, bumper of your car or tail light of your car. So this is the recycling process. Types of recyclable plastics, almost all kinds of plastics. Thermoplastics are recyclable, not thermosettings. So whatever we use in commodity plastics like polypropylene, HDP, LDP, all are recyclable, commonly used in beverage bottles, used in containers or pipes, found in packaging, textiles, automotive parts. These all are recyclable. Just need to dispose it properly and channelize it to a proper recycling company. Challenges are, of course, there in recycling. First is contaminations. Contaminants make recycling process less efficient and more costlier. For example, if I, as a consumer, is disposing my milk pouches in a recycle bin, that's really good. But we need to move forward and rinse it first before putting into a recycle bin, so that a recycler will not have to uh, use a lot of water in cleaning that milk pouch. So that contaminates, not only increase the cost, but also it's not environment friendly when you are using a lot of water. Another challenge is sorting mixed plastics. There are many types of plastics, and with the innovation on daily basis, new compounds, new alloys are coming up. So it needs experience and technology to identify plastic and then separate that, segregate. Non-recyclable materials mixed with recyclables. When I say most of the materials can be recycled, but non-recyclable, technology-wise, you can recycle all kinds of thermoplastics. But sometimes it is not economically viable. If there is a lot of contamination, it can spoil batches of recycled plastics. So these are major challenges. What are economical barriers? The cost of recycling can be high due to energy and labor expense. It will be much higher in case of multi-layer packaging and other materials which has challenge of other types of contaminations. When we say contamination, every print on the plastic material is contamination to the plastic. Every dust, oil, any food product left in our packaging material is barrier to of the economics in the recycling sector. Yes, market demand for recycled materials can be inconsistent, but later, currently there is huge demand in good quality recycled materials. Now, it is not only a business of quantity. Now it's a quality also. You need to provide quantity with best quality materials to make it more sustainable business. Investing in recycling infrastructure is huge. But with the help of these new rules, thanks to central government, Ministry of Environment, CPCB, now a lot of investment is coming up in this sector. So technical limitations are also there. Current technical limitations are efficient recycling of all kinds of plastics. A lot of investment is coming in PET bottle recycling, but still there's huge gap in polyolefins, polypropylene, HDP, LDP, and other engineering polymers like ABS, high impact polystyrene, general purpose polystyrene, polycarbonate, etc. Developing new recycling methods can be time consuming and costly, but we don't have to reinvent wheel. So guys, there are guys who are working very hard and smart to make efficient machines with latest technology. There are now machines with AI-based sorting mechanism. So these limitations can be overcome with that. Some plastics degrade in quality each time when they recycled. Yes, of course, there is downcycling if we are not using the right kind of technology. With the right kind of technology, it degraded less. For example, if you are recycling, say, red color of any bucket or any product, so it cannot be converted back into transparent or white or green. So that is limitation. So it's better if government proceeds with reducing any color in plastics or any other types of additives. So that in that way, recycling companies can overcome this technical limitation. So this is a very good example of, I just want to share what is the recycling percentage of PET, PP, polypropylene, high density polyethylene, and low density polyethylene across some countries in Europe. When we see in Germany or Austria and other countries, the highest percentage of plastic being recycled is PET. So here we can visualize much better way. The orange one is PET. In every country, orange one is the tallest building. And second comes HDP. Third one is polypropylene, and fourth one is LDP. So just want to share what is the reason of that. Why PET is most recyclable, whereas it was not being recycled just 20 years back. In comparison to all polyolefins, it has been there. The recycling of this has been there for last 40 years. So why it is organized? Because PET can be identified very easily that this is bottle is of PET. Whereas when we see any rigid product of polypropylene and HDP, it is very difficult to identify until and unless you know a lot about plastics. So when you cannot identify polypropylene and HDP, it's difficult to make a chain of someone who is collecting waste at the source and channelizing it to recycling company. So that is a very big challenge. Why HDP is at number 2 and PP is not there? Simple reason is in Europe, milk comes in HDP jugs. So they can easily identify if it is milk jug, means it is HDP. Third one is polypropylene. And why LDP comes last? Very simple reason, because LDP is mostly used in flexibles. And flexibles, it's not very profitable for a waste picker, because he has to go down a number of times to collect a 1 kg of LDP waste. So that's why it is not being collected a lot. Another reason is many contaminations happens with the flexibles. Sometimes we put say a food waste in wet waste bin, but packed in plastic packaging. Sometimes we put, say, diapers or any other contaminated material packed in LDP polybag and then put it in a waste bin. So that is a contaminated material and cannot be recycled easily. So opportunities, yes, this is lovely subject I want to share. This is a lovely topic. As I shared earlier twice, huge opportunities are there for recycling companies, especially in India. Innovation and tech, there's opportunity in innovation and technology. Advances in recycling technologies improve efficiency and reduce cost. So when we say improvement in technology, means starts from segregation, AI-based segregation machines. Then shredding, of course, the best quality shredding machine will give you a better result. Washing, test labs. There are many, when I say different types of polymers, it doesn't mean that if I'm discussing polypropylene, then it is a single material. No. There are many types of polypropylene depending upon their properties. For example, in our cars, automotive sector, dashboard of our car is polypropylene and bumper is also of polypropylene. But there is a major difference. Dashboard is stiff and bumper is flexible. Reason is we need to use approximately 20% talc mineral in polypropylene to make it stiff, and to make it flexible and more impact strength, we need to use EPDM in some percentage with polypropylene for car bumpers. So these type of technologies, there's a huge gap, I mean, for developing a new polymer with recycled material to replace virgin polymer without losing any properties of the material. There's a huge opportunity in this sector. Development of biodegradable plastics reduces the environment footprint. Yes, there again is a very huge opportunity. When we say biodegradable or compostable, we think that it will be it will degrade or compost in natural conditions. But that's not true with the current material we have. A lot of research development is going on in this sector. And soon, I believe, there will be a material which will compost or degrade in natural conditions. That will be real biodegradable and compostable material. There's a lot of opportunity in research in chemical recycling coming up. I mean, when we all know that we are facing challenges of alloys and contaminations of different types. Chemical recycling will help, and it will have edge over mechanical recycling. Policy and regulations, yes. Government incentives can encourage businesses to adopt recycling practices. We need that. In India, it's a very big country. There are some states where recycling is happening in a good numbers, but there are some states which are lacking in recycling. So we need government incentives to encourage recycling companies to have unit in, say, Northeast or Goa or many other states and cities. We need centralized effluent treatment plants. We need centralized fire safety equipments. So these type of incentives can definitely help recycling sector and will definitely help to manage waste. Regulations can mandate recycling and reduce plastic waste. Thanks again to Ministry of Environment and Central Pollution Control Board coming up with very impactful EPR rules. And thanks again because they are amending those rules after discussion with all stakeholders, and as and when required, amendment has been done. Extended producer responsibility are helping recycling in many ways. Market potential with increased consumer demand and for sustainable products, both is there. I mean, there's huge demand for good quality recycled materials now. Expanding recycling sector creates business opportunities. Companies can gain competitive advantage by integrating recycling into their operations. Examples of some successful recycling programs: cities like San Francisco have implemented comprehensive recycling programs, achieving high recycling rates. Companies like Unilever, Coca-Cola have set ambitious recycling and sustainability goals. I'll give you an example of Coca-Cola. The drink comes by the name of Sprite. Now it is coming in transparent bottle in place of green, which they were using earlier. It will also help, as I discussed earlier, colors or any additive is a major reason of downcycling. And when you are coming with transparent bottles, it will definitely help to get a good recycled material. Community initiatives have successfully promoted recycling awareness and participation. I also want to share our company's initiatives in Delhi, where we have tied up with the Municipal Corporation of Delhi and opened 2 refill centers where consumers come and refill their empty bottle of detergent or hand wash in exchange of plastic waste. So these type of innovative recycling programs, collection programs can definitely help environment. Recycling of difficult to recycle waste, for example, MLP needs innovative recycling technologies. Our company has recently got a patent where we have separated layers of multi-layer packaging. We are working with a German organization to build a machine which can scale up this separation of layers in multi-layer packaging and get a good recycled material. 3D printing is another initiative which can be taken, and there's a lot of recycled products can be made through recycled 3D printing yarns. So what to do next? Call of action: encourage participation. Individuals can contribute by properly sorting their waste and supporting recycling programs. This is very important for each and everyone. Businesses can implement sustainable practice and invest in recycling initiatives. Together, we can create a cleaner and more sustainable future. Future outlook is continued innovation and investment in recycling technologies, and it will drive the industry forward. Policy support and public awareness will enhance recycling efforts globally. The long-term benefits include a healthier environment and a more sustainable economy. So Thanks to all of you. And this is a glimpse of what we segregated bottle caps, first polymer wise and then color wise. And with the help of Bisleri, we converted this bottle cap regrind into beautiful patch. Thanks. And I'm looking forward to your questions.
Thank you, Mr. Pahwa, for an engaging session. We will now open the floor for the questions. There are a few questions in the question answer box. I'll read them out. First one is how pyrolysis of particular type of plastics helpful in recycling, like plastic diesel. How much percentage of plastic is recycled through pyrolysis of plastic,
Very
keeping
good.
in consideration of harmful gases?
Okay. So it's a very good question on pyrolysis. And unfortunately, pyrolysis is not economically viable, especially in India. I'll give you a comparison of Europe and India. In Europe, source segregation is much better than India in most of the countries. So they get plastics altogether. Their limitation is they cannot identify plastic, so that they cannot recycle it. And the kind of machines they use to segregate plastics gives them 92% accuracy, which again is not good enough to get good recycled material. So what they do is they either use these plastic waste into waste to energy plant to make energy, or in pyrolysis plants to make oil. But here in India, when there is a very robust system of waste collection and recycling, most of the good quality waste goes into recycling system, giving it a good price for a waste aggregator. Whereas pyrolysis needs a material without PVC and less contamination, and it can give you cost or maximum of 7 to 8 rupees, which is not viable. So I believe pyrolysis is not viable in India in current situation. Maybe with the help of a technological upgradation, we will have a good plants.
Thank you, sir. Second one is innovation of PET bottles. PET bottle recycling is highly appreciable, but is it possible to recycle PET films? Is there any organization or industry working on polyester film recycling in India?
Yes, of course, polyester film. As I said, all kinds of thermoplastics can be recycled. There are sometimes limitation of cost involved in that, but there's no cost barrier in recycling of PET film. We are recycling PET film, and many other companies are recycling PET film. It can be recycled. The transparent one can be easily recyclable, fetch good price also. There's a limitation in price of print PET film, but yes, it can be easily recycled.
Next one is, I would like to know, is there any progress in FRP thermoset plastics recycling process?
Okay. So as I earlier said, all kinds of thermoplastics can be recycled. When you say thermoset, so plastics are mainly divided into two, thermoplastics and thermoset. Yes, there are some technical, again, research and development is going on how to recycle thermosetting. But unfortunately, mechanical recycling is not possible with that. And there are some researches going on to crush them or pulverize them into powder and use as filler. But we are expecting some more technical upgradation to get good value out of it.
Thank you, sir. Next one is how to separate layers of films while recycling. Some layered products have a color, so is it possible to separate that used pigments during recycling?
Can you please repeat question?
Yes, sir, sure, sir. How to separate layers of films while recycling? Some layered products have a color, so is it possible to separate that used pigments during recycling?
Oh, great. So two questions are there. One is how to separate layers.
Layers of films while recycling.
In multi-layer packaging, layers, you need to separate it before the process of actually shredding it, grinding, or washing it. So as I shared earlier, that we have patent on that. We separate layers with a particular chemical and at a particular temperature, where we have separated layers. And yes, of course, colors are a big challenge. You cannot remove colors if you added ones, and you can manage with colors to reduce the impact of color. You can use a titanium dioxide and many others. But yes, you cannot remove colors when it's there.
Thank you, sir. One last question is there. What about PET fabrics recycling?
Great. Another very important question. So again, I'll share my experience on this. We are recycling polyester clothing tags coming out of from H&M post-industrial waste. We are recycling it. Polyester is also belongs to the same family of another polymer, PBT, which is normally used in electrical applications. What we have done is we have compounded polyester fabric waste with PBT. Yes, of course, different MFI material and with some compatibilizers, and uses this PET PBT compound for electrical applications and car door handles both.
Thank you, sir. Thank you to everyone for your thoughtful questions, and thank you again, Mr. Pahwa, for addressing them so clearly and thoroughly. As we come to the close of today's session, I would like to take a moment to express our heartfelt gratitude. On behalf of Plastindia International University, WAPI, I sincerely thank Mr. Pahwa for your engaging session on India at the Crossroads, turning recycling into $5 billion economic powerhouse. Your industry insights and forward-looking approach to recycling have been truly enlightening for all our participants. To all our participants, thank you for joining us for this 8th edition of the Parivartan Webinar Series. We hope you found today's session enriching and engaging. Thank you, everyone, and
Thank you
goodbye.
so much. Thank you so much.
Thank you, sir. And drive future innovations.